Obstacles and preserves. In this video, we'll use Edit Model to remove components, and we'll create obstacle and preserve regions. In Fusion 360, we want to carry on with our part consolidation dataset. We're going to navigate to Generative Design, and we'll begin by going into Edit Model. The first step in the process is to remove all the bodies and components that we don't need. There are some that are going to be helpful for us to retain, but for right now, let's go ahead and remove objects that we know that we won't need. So in the machine interface, I'm going to begin by taking a look at body 1 and body 2, right-clicking and selecting Remove. Next, we're going to look at the 3 bolts that are holding the sheet metal pieces together, and we'll remove those as well. For right now, I don't need the original hardware, so I'm going to remove that as well. For our sheet metal brackets, while we don't need to keep the sheet metal brackets around, it will be helpful to have some of the geometry so that we can use it as a reference. So what I'd like to do is first, I'd like to make sure that we capture some of this data. I'm going to begin by creating a sketch, and I'm going to use this exact geometry. We're going to finish the sketch, and then on the other side, I want to do the same thing. I'm going to create a sketch on this face, but I'm going to use my circle tool with C on the keyboard, and I'm going to create a larger diameter circle. In this case, we're going to set it to 13 millimeters for right now, and we'll finish the sketch. Now I can go into my sheet metal bracket top, right-click and remove, and those sketches will be left behind. Then the sheet metal bracket bottom, I can remove that as well. Now I can create some of the preserved geometry. We already know that we need to keep the machine interface, but I also want to take a look at the geometry needed for the pivot. So we'll start by creating an extrude, and I'm going to bring this over, and I'm going to take that a distance of 5 millimeters. We're going to say OK, we'll rotate this around, and on the other side, we're going to repeat the extrude. This time, we're going to take this in a distance of 5 millimeters as well. Notice as we do that, at 5 millimeters, we're beginning to hit the link. That's because originally the link was not perfectly centered. There was a small gap. And also note that on the right-hand side, we actually had a thinner piece because the threads didn't go all the way in. So I'm going to set this to -4 millimeters, but I want to use a 2 sides. And for the other side, I'm going to set it at -1 millimeters to give us the total of 5. Now that I have those 2 bodies, we also need to deal with creating some sort of obstacle. We don't need the link, but we will need to track the linkage and its full motion to make sure that we are avoiding it. In order to do that, I'm going to start a new sketch, but let's take a look at where the default origins are. So you can see that we have our XY plane, and we have our XZ plane, and then we have our YZ plane. And this should be right in the middle, but you'll notice that it's not. So what we need to do is we need to make a plane that's right in the middle, or decide that we want to sketch directly on the face of our part. So in order to do this, I am going to sketch directly on the inside face of this piece here. We might need to rotate it around, and then we can click and select Create Sketch. From here, we're going to begin by using our circle tool, starting at the center of our pivot, and we want to create a circle that is a 20 millimeter diameter. This 20 millimeter diameter exactly matches the outside of that pivot. The next thing that we want to do is we want to add some points out in space where we think this is going to move to. So on the right-hand side, I'm going to draw a center diameter circle. Then I'm going to use my horizontal vertical constraint to make sure that these are horizontal with each other. Then I'm going to use D, or the dimension tool, to add a 12 millimeter diameter. And then I'm going to give it a distance of 30 millimeters. When we take a look at the distance of 30 millimeters, you can see that the pivot is actually quite a bit farther away from that. So this is not going to be nearly far enough for us to track the entire motion. So in order to account for that motion, we need to go a little bit further. We double click on this and we set it equal to 50. You can see that goes a bit farther than we need to. So in this instance, we're going to go to 45 millimeters. Next, I'm going to go into my linkage part. I'm going to completely hide it. This will make it a little bit easier to use my line tool. And I'm going to connect this side. I'm going to do the same over here as well. Then I want to use my constraints for a tangency constraint. Applying tangency to each of these lines in both circles will get us a fully defined sketch at this point. I'm also going to add a vertical line from the center. I'm going to bring this up and then hit escape to get off my line tool. This is going to be a construction line for a mirror, so we can select it and turn it into a construction line. Now that we have the right side drawn, we can use our mirror tool. We can select the objects that we want to mirror, and then we can select the mirror line. Now that we have both sides, I'm going to turn the upper edges into construction. Then I want to go to my Create and select Arc. We're going to go from one side to the other, and then once again, we'll go to our constraints and we'll apply a tangency constraint. Once we have our tangency constraint, we also need to make sure that we understand exactly what we want that upper arc to look like. So I'm going to hit escape to get off my constraint tool and begin pulling this around. The center point of this arc needs to be at the center point of the link. So we'll make those coincident, and now we have a fully defined path. This is going to represent the full travel of the link as it moves through its motion. And you'll note that we didn't go all the way to a horizontal or below horizontal. We simply put the pivot points completely horizontal from each other rather than rotating all the way down. You'll notice that the original geometry of the link doesn't match what we drew, but what we're defining here is an obstacle. And that obstacle needs to make sure that it keeps any geometry that's being built out of this area. Next, we're going to finish the sketch and we want to create an extrude. So E on the keyboard will allow us to select the areas that we want. And in this case, I want to make sure that I grab all the areas of interest. And then I want to pull this completely to the other side. So I'll again temporarily hide the link and select Extent Type to Object and come all the way to here. This is going to be a new body. We don't want to join it to our preserves, but now we have something that represents both sides. The last thing that we need to do is we need to define a few more obstacles. And for this, I'm going to use my connector obstacle tool. And I want to go from one side completely to the other. I'm going to pull this all the way through, noting that on this right side, we'll simply have threads poking through. So I'm just going to make sure that it extends slightly past. Then I want to include a bolt head as well as tool clearance. The bolt head needs to match or be slightly larger than the bolt that's being used, and in this case, 18 millimeters will be fine. We'll select OK, and the last piece of the puzzle is hardware that's going to represent hardware going through these plates. Using the connector obstacle tool, I'll simply select it, include a bolt head, and tool clearance. We can increase the length of the tool clearance as needed to make sure that we are building around any specific obstacles. I'm going to repeat that process on the other side, using all of the defaults, but notice that it's going the wrong direction. So for shaft length, I'll enter -12, and then we'll use bolt head as well as tool clearance. We'll set the tool clearance distance at 35 millimeters. You'll notice that it's automatically selecting the tool diameter, so we'll reset that and change the tool length to 35 millimeters. Once we say OK, we now have hardware in one single position, but we need to either copy it, recreate it with the connector obstacle tool, or potentially create a pattern. What I want to do in this instance is take a look at creating a rectangular pattern. We're going to do this with bodies. We'll select this body, and then we can determine the direction by selecting an edge on our plate. As we pull this out, we're only going to need 2 instances in each direction. And we simply need to make sure that the distance that we're traveling is going to match exactly what the plate is. In this case, 28 millimeters in both directions will work fine. We can repeat that process on the other side using our right-click marking menu. We'll select this body. For the direction, we're going to select a linear edge on our plate, and then we'll go 28 millimeters, 2 instances, and we'll repeat the process for the vertical direction. 28 millimeters and 2 instances. Now when we finish Edit Model, we can come back and select all the geometry we need. In this case, we're going to add the large extrude to our obstacles. And then for our preserves, we're going to select all the areas that we need to retain. Now we can see all the areas that it's allowed to build in and the areas that we need to avoid. Notice that we have unassigned geometry and there's a single body we forgot to remove. We can go back into Edit Model, and inside of here, we can go through and we can select the link and simply right click and remove it. Then we'll finish, and note that we're back into our generative design. We can go back to a home position and we can select Save.